Hi, I'm Andrew and I'm a curator for rocks and minerals at Amgueddfa the Cymru National Museum, Wales. I'm here in the mineral store, which is one of the areas that Jana and I both work. We've got about 30,000 minerals housed in this storage area here, and this is also where we keep our meteorites. And I want to show you some of my highlights from the collection. First of all, we've got this meteorite here. This is a palisite. It's a palisite called the Krasnoyarsk palisite. A palisite is a stony iron meteorite with gorgeous olivine crystals held in an iron-nickel matrix. And all of the palisites that we have in our collection are actually cut sections, slices. But what I love about this meteorite here is it's all one piece, so you can see the three-dimensional structure of the iron nickel matrix, because a lot of the olivine crystals have been weathered or blasted out. It was part of a large mass that probably exploded over Krasnoyarsk in Siberia in Russia. The main mass of this meteorite was found in 1749, and it was the first palisite studied as a known meteorite at the time, and the group of palisite meteorites were named after the botanist and zoologist Pallas, who first saw this meteorite and first studied this meteorite. One of my second favourite objects is this here. It's not a meteorite, but it's a rock that's actually formed as a result of meteorite impacts. It's something that we call an impact breccia, swavite. And it is formed when a massive meteorite strikes the ground with such force and velocity that the energy involved usually vaporizes the meteorite that hits the ground and the rock in the immediate area, but it also superheats and breaks up a lot of the other surrounding rock and throws it up into the atmosphere. And this superheated rock comes raining back down, and because it's so superheated, it gets welded together. So when scientists first studied these rocks, they actually thought they were volcanic in origin. It wasn't until they understood more about meteorites and meteorite impacts and the structures that are formed that they understood that this rock was actually formed as a result of a really high energy meteorite impact. This particular rock is from a place called Nordlingen Ries in southern Germany, and a large meteorite struck the ground about 14 million years ago, and it created a crater about 24 kilometers across. And my final favorite object is this stony meteorite here. It's a chondrite meteorite, one of the most common meteorites that you find in falls across the world. About 86% of all known falls are chondrites. But what I really love about this meteorite is the way it was recorded and documented. It exploded. A huge fireball was seen streaking across the sky in Siberia and Russia again in February 2013, and in this particular, it was really well documented. It really well recorded on CCTV, and a lot of cars in the area have dash cams, so there was a lot of really great footage of the meteor coming into the atmosphere. And it came streaking across the sky. The original mass was probably thought to be about 20 meters across when it first came into the atmosphere, but as it came through the atmosphere, it exploded into countless pieces, and most of the meteorite was probably vaporized high in the atmosphere, but a lot of pieces still came raining down over a wide area in this part of Russia, and these are a couple of pieces of that particular meteorite. When the meteorite fell, it fell into fresh snow, and it was immediately collected by a lot of local residents. So as a result of that, the pieces that we have here are really, really fresh. The fusion crust, which is the thin melted layer that's formed as a meteorite comes hurtling through the atmosphere, is still really, really fresh and really, really black on this specimen. A lot of specimens that we might have in our collection may have been sitting on the ground for a really long time before they're found, so they get really quite weathered. And the cut section in this meteorite also tells a really good story as well. We know that the meteorite was formed probably about 4,550 million years ago, and around 115 million years after its formation, it collided with another. It was formed in an asteroid, this meteorite, and it collided with another asteroid in space, and it caused melting and lots of fracturing through the meteorite, and that's recorded in this cut section here. As I said about the footage that you can see about it, I recommend Googling Russian meteorite or looking at YouTube and looking for Russian meteorite or Chelyabinsk meteorite, and I promise you won't be disappointed in the footage that you see there.
Hello, here are my 3 interesting picks from the meteorite collection. The first 2 are quite small, but they have really interesting stories associated with them. The first is this one. It is a chondrite, quite an ordinary type of meteorite, the second most abundant type. It fell in East and Yorkshire in 1795, but it's not actually the meteorite that's the sort of theme of the interest. It fell in front of a farm worker. It made a little crater. He had the sense to pick it up, and it's about the size of a bread loaf, weighing 25 kilograms, and he took it back to Cottage. This is known as the Cottage Meteorite. And that belonged to somebody who was a bit of an entrepreneur. So he opened up Cottage as a bit of a sightseeing feature. Many people came to see it. Not that anybody really knew what it was. It had something that came out of the sky. Sowerby, a famous mineralogist, came and looked at it, and he included it in his mineralogy book. But into the early 1800s, Sir Joseph Banks, who was then the president of the Royal Society, came to see it, and he paid a shilling to see it. And he made the correlation between this rock and one he had seen in Italy the year before that was known to have been associated with a fireball. So that was really good. That was sort of a good point. However, he didn't make the association that it had fallen from the sky. The fireball was a product of the meteorite. He thought that actually the fireball had made the meteorite. And it wasn't until perhaps the middle of the 1800s that it was generally accepted that meteorites were space rocks and had travelled to Earth. My second specimen, equally unprepossessing but equally important and significant, is a shergotite from the Shergati mountains in India, named after a meteorite that fell there in 1865. It's about 180 million years old, and it's a volcanic rock. But the most significant thing about it is it comes from Mars. So unlike the moon, where we have rocks collected by Apollo, we have no actual specimens from Mars yet. We have data, but not actual specimens. But we do have about 291 meteorites that have been verified as coming from Mars. So that's what makes this meteorite really, really special. And then finally, my last specimen is the Iendi Meteorite from Chihuahua area of Mexico. This fell in 1969 and was seen to fall. It's quite a rare type of chondrite. It represents just 4% of the meteorites we know. But this one fell in massive amounts, about 2 tons of it. It was instantly collected, and some parts of it went back to America, to Houston, to be used in a dummy run for analysing the Apollo 11 moon rocks. As a meteorite, this one is really interesting. It hasn't been very altered, but it does contain carbon. So the fact it's not been heated and contains carbon means it has potential to contain amino acids. It's an indication of life. It also contains these teeny white little flecks, and those are calcium aluminium inclusions, and they represent the first grains that crystallised when the solar system was forming. And an amazing thing that this rock has also been analysed and found to have are grains that are actually older than the age of the meteorites. So those must have come from outside the solar system when the solar system was forming.